A parametric equation is a group of functions that depend on the same parameters. So in 2 dimensions, the point here is represented by x and y, and any point on the curve can be obtained in the closed interval AB by changing this single parameter t. So for example, if t equals a, then we have x and y at a. And we can find the derivative, or the slope of the tangent to the curve, at a point by differentiation using the chain rule. So the derivative, or the slope of the tangent to the curve, is dy dx, which using the chain rule is dy dt by dt dx, which is the same thing as dividing dy dt with dx dt. And the derivative is defined if the derivative of x with respect to t is not equal to 0. Let's find an anti-clockwise parametrization for a semicircle with a radius of 2. Well, a parametrization defines every single point on that curve using a single parameter. So if we look at a point on this curve, then we can visualize that our parameter t is the angle. So we can define the x-coordinate as the radius cosine t, and the y-coordinate can also be defined using trigonometry as 2 sine t, where t is between 0 and pi for the semicircle. So for t equals 0, x is 2 and y is 0. And for t equals pi, we can see that x is equal to negative 2 and y is equal to 0. So therefore this is indeed an anti-clockwise parametrization. Given this parametrization for a semicircular curve, find the slope of the tangent to the curve at t equals pi on 4. Well, that's the derivative dy dx, which is equal to dy dt by dt dx using the chain rule, or dy dt on dx dt. So dy dt is 2 cosine t, and dx dt is minus 2 sine t. So the 2's cancel. And at t equals pi on 4, this evaluates to 1 on root 2 on minus 1 on root 2, which is minus 1. So where the angle is pi on 4, or 45 degrees, the slope of the tangent to this curve looks something like this. And that makes sense.